So in this lesson, I'm going to look at how we can sketch graphs which have a sum or a difference of a cos and a sine expression. So you've already seen that you can write a cos plus a sine or a cos minus a sine or the other way around. A combination of cos and sine can be expressed in a single trig expression, and that's known as you're writing it in the wave function form when you do that, and that's what you've been practicing up to now. So we're now going to go a bit further with that, and actually once we've found the expression, then going to go on and sketch the graph. So this one here, you begin as you would normally, writing the cos plus the sine part in terms of your single expression, which here is the k cos x minus a. And remember, it is this next line that earns you the first mark, where you refer to the addition formula if you need to. And also remember, with the cos one, it's always the opposite sign. So if you've got a minus in the bracket, this is going to be a plus. So you've got plus. Remember to put your k again, and you've got sine x sine a. You're then making sure that you know where your terms are. So there's your cos term there, there's your sine, and here. And you can help yourself by making sure you're aware of what's round about your cos x. Your coefficient here, remember, is the cos a term, so then you've got cos x, and this one, your coefficient is the k sine a. That's what's multiplying your terms. So there's your cos, there's your sine expression. So you want to make sure that you're matching up left hand side and right hand side. You can write them underneath just to see, making sure you can use highlighters or whatever, basically equating your coefficients, and that produces your two little mini equations. So you get your k cos, you can see here that your k cos a, right, that needs to be equal to the 7. Right, so whatever's multiplying your cos x, right, they need to match, and your k sine a, that will be your other one, right, and that needs to be 6. Everything about that is all matching. There's no negatives to worry about or consider here. So we can write down our two mini equations. K cos a equals 7, and your k sine a is equal to 6. And at that point, you've then worked out your second mark, having both of these correct. Remember then to produce your k value, you're squaring and adding these two equations together. So you're going to get k squared equals 7 squared plus 6 squared. That's going to give you k squared is equal to 85. And of course k will therefore be the square root of that. You've now to work out your a. So tan is worked out by taking the sine expression, so k sine a over k cos a, to show that you get the 6 on the top of that and the 7 on the bottom. Everything about this here is all positive, so actually that's where your 3 ticks would be in the first quadrant. So you just need to go to your calculator, right, knowing that we're in the degrees, make sure your calculator's set on degrees. So get tan to the minus 1 of 6 over 7 is going to give us 40.60. 1, 2, whole load of other figures. We'll round it to 1 decimal place, so we're going to have 40.6. And that last bit is then to write down what your original expression is. 7 cos x plus 6 sin x equals root 85 cos x minus the 40.6 that you've just worked out. And remember, that's how you earn your fourth mark. Your third mark is the k value, Fourth mark is getting the angle and then putting it into the expression. Now, the next part, the part B, is the bit we've not really been doing, but this is asking you to sketch the graph of this expression. So now that we know that we can go from 7 cos x plus 6 sin x, it's exactly the same as this single expression, and we know how to sketch, or by now we should know how to sketch a cos graph, and the fact that you've got this minus bit in here, that's your what we call the phase angle, and this is just going to involve us in doing a bit of a shift. But before we get to that part, we will break it down. So you're going to be sketching this graph. Here's y equals root 85 cos x on its own, right, before we do the bit with the minus 40.6. When you sketch a graph, there's some key things about it that you should be aware of. Try and make sure the turning points are indicated, if you can put in any y-intercepts, and the matching y-coordinate for x equals 360 at the other end, and also your points on the x-axis. So for the basic cos graph, sticking a number in front, remember all that does is it just changes your maximum and minimum value. So you can quick sketch there of your axes, right, and reminding yourself the cos one is like the big dipper, so it's going to start at the top, root 85, come down there, and then that'll be your minimum turning point, go back through there, and then this is what I mean about the y coordinate for x equals 360, you're back up at the root 85. So that's your graph and the basic shape of that, your wave, as best you can. And basically all that's now going to happen, that's what root 85 cos x looks like. So to get to the one we're trying to get to, that minus 40.6 in brackets, so this bit here, just basically means that it's this. You should know from the second topic that we did back, or the first topic actually I think we did after the summer, was on functions, and you looked at how you can connect between graphs. So this minus 40.6 inside that x means a horizontal shift, and the minus means to the right. So all of the points that we've got here, basically the same shape, but sliding the graph 40.6 to the right. So that means you're going to add on 40.6 to the 90, so that's going to give us 130.6 where it's crossing x-axis. Likewise with the 270, you're going to add the 40.6, so you're going to have 310.6, and so on. Now what will happen when you slide across the way is that your turning point will have moved to, instead of being at the 0, it's moved to 40.6 root 85. So your graph at this end here has come down a wee bit. To work out this point here, that's your y-intercept, and that's where if you do this little bit at the side that I've got written here at the side, to work out the y-intercept, put x equals 0 into the equation of the curve in this format here. Just do it in your calculator, you'll see it comes out roughly about 7. So your graph is doing that. I've just said, right, these key points that we had here, right, so that 90, so you're doing, it's going that way, and you're doing like 90 plus 40.6, right, and that's how we get to the 130.6, right, and this here, you're likewise with the 310.6, that's because it was 270, right, 270 plus the 0.46, right, that's how you get to the 310.6. So they're your points on the x-axis, but apart from that the curve has just slid a wee bit. Your turning points likewise, you had 0 here, right, that turning point, and it moves 40.6, and this one down here, which is 180, we'll have add 40.6 onto that, and that's where you get the 220.6 minus root 5. So that's all shifted to the right, and that would basically be your graph. But the bit about making sure you start and end at the same point, so this 360 is not right back up at root 85, it stops in line with where the 0 part is, so at the 7. So they should be at the same height. Your graph is continuous, remember, so even though here we only sketched a wee bit of it, right, your graph's doing that, and on this end it continues, and that's why you can think about actually the graph sliding, right, so your graph's doing that and moving that 40.6 units, and that's why it ends up looking a bit like that. And that would be it. So you need to sketch, get the right place, know that it's shifted a wee bit, indicate least your turning points, make sure you're ending up there. So not particularly easy with the numbers that are involved there, but you should have the idea of how to do the graph sketching. So second example, I mean you can maybe pause the video and have a go at this one yourself. You should at least be able to do this first bit. So you're looking for, starting again, y equals sine x plus root 3 cos x. Actually, didn't mean to write the y equals bit there. We're just going with the going to write the sine x plus, so not the y equals bit, just ignore the y equals for the moment. Sine x plus root 3 cos x in the form k cos x minus a. So again, routine, k cos x cos a plus your k sin x sin a, and again same thing, your k cos a cos x and your k sin a is multiplying your sin x. Now notice here the order is a sin x term, so whereabouts is your sin x term? Here's your sin x term over here. So make sure you match like with like. Your cos x is here and here. You could rewrite that if you're comparing it. Make sure you are comparing like with like. So we've got root 3 times cos x, just changing the order, plus you've got the sin x. Essentially, remember, that's like having 1 sin x. So again, when you produce your or equating your coefficients and you're writing down what are your two equations, right, make sure, as I say, make sure you're comparing like with like and you don't just take them in order. So be aware that the order of the terms there, you do need to make sure they match up. So root 3 will be what your k cos a needs to be, and your k sin a is equal to 1. Right, and as routine, right, square and add, you'll work out what your k is. So your k squared is worked out by doing root 3 squared plus 1 squared. So of course root 3 squared is 3 plus 1 squared is 4, so k squared is 4, so k will be equal to 2 for this one. It'll be a bit easier than dealing with root 85. And your tan is your k sin a over k cos a, and here that would mean your 1 over root 3. That should remind you that of one of your exact values. Also, as well as that, everything is positive, so we're dealing with the first quadrant. If this was a non-calculator question, then you would be on your little 60-30 triangle, and you're looking for opposite over adjacent. So we're opposite to 30, right? That would be your opposite and your adjacent would be here. So it's the 30 angle that we're interested in. So, or you can go to your calculator and do this, but A would be equal to 30 degrees. So that would allow us to write that expression. So sin x plus root 3 cos x is equal to 2 times cos x minus 30. So your part B of this, although we didn't get a part, that this was actually just written as a single sketch the graph. It was straight into sketch the graph. However, in the exam you would normally be laid into that with a part A, and then the sketch bit would be part B. So that's why I split it up like that. So we wrote that in the form of the single wave expression, which we've now done, and now we can go on and actually do the second bit, which is sketch it. So hence, in order to sketch that graph, you are going to replace the sin x plus root 3 cos x with a much simpler expression, 2 cos x minus 30. So you're going to be sketching that graph. So compared to the last one, very much easier. To help yourself and identify some of the key points, I would recommend that you first sketch y equals 2 cos x. Remember, that just means your cos graph goes between 2 and minus 2, and you have your key points on the points on the y-axis and your turning points, know where they are at 180 minus 2 and so on. And then basically to draw this one, that minus 30 means it's your phase angle, so everything is going to shift 30 degrees to the right. So instead of crossing at 90, it's going to be crossing at 120, and it's going to be crossing the x-axis at 300 and so on. So your turning point will happen at 30. And remember, that does mean that where does it cross the y-axis? And if you sub in x equals 0 into the wave expression, you get y equals 2 cos minus 30, which is, if you were doing this again without the calculator, non-calculator, the negative, right, cos of negative 30, what does that mean? Well, negative 30 means the angle's going that way, and if you're doing the cos in that quadrant, it's just the same thing as working out the cos of 30, because the cos is positive in there, and from your little triangle, the cos of 30 is root 3 over 2. So you're basically doing 2 times root 3 over 2, which would be root 3. You can get that from the calculator. It's approximately about 1.732, whole of the digits. Done this wee bit here at the side just in case if you got something like that in a non-calculator paper. That's what this point here is indicating. It's just a bit below where the turning point is. So make sure your turning point is marked. That's your 30 and your 2. You either mark it like that with these wee lines, or what's a good idea is you can write the coordinates beside it. There's your 120. There's the other turning point at 210 minus 2. There's your other point in the x-axis is 30, and this point here, that should be in line with the 1.7, so it shouldn't be right back up at the 2. And that's your wave that you were asked to draw. Right, last one, same sort of routine as we've just had. Again, you could pause and go for the first bit, part A, you're expanding. This time you've got 5 sin x minus root 11 cos x. You're asked to use the sine expansion this time. So k sine x minus a. Remember, with the sine formulae, when you look at the addition formulae, that they match. So a minus in the bracket means a minus here, and you will have k cos x sine a. So if you're looking at that, there's your sine x, there's your sine x. What's multiplying your sine x? You've got k cos a. So you've got k cos a sine x minus, you're going to have k sine a times your cos x round about that. Right? There's your cos x. So k sine a and your cos x, and you're going to match, right, or compare with 5 sine x minus root 11 cos x. So because the signs all match here when you do this, so equating your coefficients, right, that will match, and here the signs match, so all you need to think about is that those two there need to be equal to each other. So equating coefficients, and you can write down your two little mini equations, which here would be k cos a equals 5 and k sine a is equal to root 11. Working out your k, right, by squaring and adding these two things together, you're going to get k squared equals 5 squared plus root 11 squared. So you're going to have k squared equals 25 plus square root of 11 squared is just 11, so k squared equals 36. So we get k will be equal to 6. Working out your angle, so you're going to have your tan is equal to your sine over cos, and for us that means that it's this one here, your root 11 is going over the 5, and from that you know that everything is in the first quadrant, right? By your CAS diagram, if you go through where all the ticks need to be, the one that ends up with a 3 in it is the first quadrant. So you can go to your calculator, right? We are in degrees still, so tan to the minus 1 root 11 over 5, and you will get 33.5573, whole load of other figures, and we can round that to 33.6 degrees. So your expression that we started with, 5 sine x minus root 11 cos x, becomes the single, it's the same thing as the single sine expansion, 6 sine x minus 33.6. So that's part A. Part B is then to go on and draw that. But notice that this time, as well as having that expression that we've just looked at, they've also got this plus 2 on the end. So a wee bit more complicated this time. So what you have to think about is, well, I know what this bit is, this sine x minus the root 5 sine x minus root 11 cos x. I've just come up with an alternative expression for that. That's the 6 sine x minus 33.6. So basically, to sketch all that, we replace the sine and minus the cos bit with that. So this is the graph here that we need to sketch. So actually what we need to do with this one is think about the most basic graph there, the 6 times sine x on its own. Then you want to be thinking about, right, well, how would I do that phase angle? So go from your sine x to sine x minus 33.6. And then the last bit is that the fact that we've got that plus 2 added on the end, you should recognise that as being a vertical shift, and shift the graph up the way. Now I would do this in stages. So I would tend to, as I say, do the 6 sine x for yourself so that you can remember or identify what the key points are. So where all the turning points are on this graph. So like at 90.90 and 6, and also at 270 minus 6. So what happens when you shift to the right and you're shifting with minus 33.6. So that means that you're adding 33.6 onto 90, which is why you'll see here when I've shifted the graph to the right, I've got the turning point at 123.6, and then minimum turning point 303.6, minus 6. On the horizontal axis, instead of crossing at 0, you're crossing at 33.6, and your 180, that's moved to 213.6. The only other point to work out was this point here, which is the y-intercept. Now, one of the things here that I would recommend is maybe marking it off your axes to help you, and go up in twos, right, 2, 4, 6. If you sub in to the wave function expression, put in x equals 0, so you're doing 6 sine 0 minus 33.6, just do it on the calculator. Comes out with a value roughly about negative 3.3. So that's why here I've labelled that point as negative 3.3. Now we're not quite finished, right? That blue graph that I've got drawn there, right? The blue graph has the equation y equals 6 sine x minus 33.6, but we've still to do the bit with the plus 2. So basically what I'm going to do, I'm going to think is that graph is going to be shifted 2 units up the way. So when you shift it 2 units up the way, right, all your key points, right, have just moved, but it's still basically the same shape. I know it's a wee bit wobbly looking there, but your turning point is now, instead of having a y coordinate of 6, it's now got a y coordinate of 8, and your turning point at this point down here, I mean, you can draw this on another graph, will have a turning point of 303, right, that point there is 303.6, negative 4, so it's still the same basic shape, but everything has moved up, and that's it. That's your graph drawn. Your more complicated one, we'll make that graph red so it's different, and you can see, right, the red graph is the one that we've been trying to draw. So not the easiest ones to draw, but that's the idea with these sort of things. Build it up in stages. Always start with the basics. Think about where everything is shifting to, how many degrees or whatever it's moving. So maybe go back over and have another little look at these, or look at the notes and try them for yourself.